Hello everyone, you are all welcome to lecture number 1261, and today's topic is the reactivity of a molecule is determined by the imbalance of the electron in the bond, or in other words we can say that the displacement of electron either of sigma bond or pi bond, either on demand or by the linkage of some electron withdrawing group or electron supplying group along the bond, plays very important role to become whether reactive, less reactive, and that will be the factor of getting more or less product after reaction. So the first factor is that is called inductive effect. Inductive effect is permanent effect, and it is along the sigma bond, covalent bonding, and this effect is there when some different group of atoms or atoms which are linked to the carbon bond. There are two type of grouping. One group, if it is electronegative, it may pull the electron along the covalent bond of carbon, and the other one is once it has lot of electron rich which can supply the electron to carbon chain. So in this way we have two type of that is inductive effect, either positive or negative. It is a permanent effect. And the second one is that is called electromeric effect. Electromeric effect is by the demand of the reagent, whether it is acidic means proton. If proton is there, acidic condition, so the pi electrons will be shifted and there will be polarization of positive negative charges, and it is a temporary charge and it is on the basis of the reagent demand. The third one, that is called resonance effect. Resonance effect means where such type of compounds are there where there is alternate double and single bond, and in this way the molecule will be having resonance hybrid, pi electrons will be delocalized, and also there it may be sometimes meta-directing, ortho-para-directing group. Meta-directing group means that is electrophile. Once electrophile is attached to any resonance hybrid, the meta position will be activated for attack, for reaction, and the other is electron rich species nucleophile like OH. When it is linked, then the incoming group either will go to ortho or para position of the benzene ring. So that's why there are two type of grouping to attack to aromatic or benzene ring, or we can say resonance hybrid. Either it is meta-directing group or ortho-para directing group. So here I am discussing the first displacement of electron on carbon-carbon bond, that is covalent bond. Commonly, if it is single bond, it is called sigma bond, where the overlapping of two orbitals are in front axis, axis to axis, where the two electrons are held up. And the one condition is that if along the carbon chain, if there is more electronegative element or group of atoms are attached, if I say more electronegative means as compared to hydrogen, then there will be displacement of electron towards more electronegative group or group of atoms or atom, and electronic density will be polarized, and there will be development of temporary charges, and it will be either positive or negative temporary charge. The one which is pulling the electron, most electronegative item like chlorine, bromine, iodine, hydroxy group, so many other group of atoms, they can pull the electron and it will carry negative charge, and rest of the carbon atoms will carry temporary positive charge. So here the inductive effect, how it plays the role in reactivity of the molecule in chemical reaction mechanism. The electron cloud in the covalent bond between two unlike atoms is not uniform and slightly displaced towards the most electronegative atom along the carbon. If all the hydrogen atoms are not similar, one is different like chlorine, then there will be displacement of electron along the bond, and it causes permanent effect and has temporary positive or temporary charges, and it is denoted by this sign. By this sign, if this sign is there in any reaction, it shows that inductive effect is there in the reaction mechanism. That is A part is where the atoms or group of atoms which are more electronegative as compared to hydrogen atom are said to have negative inductive effect. So here like this, once more electronegative atom is linked to carbon chain, this type of inductive effect is called a negative inductive effect, where the sigma bond is polarized. Bond polarized means electrons are displaced towards most electronegative atom like chlorine. Such condition is called negative inductive effect, and they have tendency to attract electrons. For example, C6H5 OH, OR, iodine, bromine, chlorine, fluorine, acetate, COH, and cyanide, that is Cn. These grouping or atom, they are known as towards increasing inductive effect, and that increasing inductive effect is in negative direction. That is called negative inductive effect. The big condition is there where the atoms or group of atoms which are attached to sigma bond and they are not pulling the electron towards itself, they are not so much electronegative as compared to hydrogen. So they will be supplying the electron to the carbon chain. Such type of inductive effect is called positive inductive effect. So the atoms or group of atoms which are less electronegative than hydrogen atom, it is all comparison to hydrogen atom, are said to have positive inductive effect, and they have tendency to supply the electron along the carbon bond, and these groups are CH3, that is methyl group, CH3 CH2 means ethyl group, and then tertiary methyl group, and then secondary methyl group. So they are all having the increasing order of positive inductive effect, and I have already told you that this effect, that is positive or negative inductive effect, works only on sigma bonding. Sigma bond means carbon-carbon single bond, and where two of the orbitals are overlapped axis by axis, and where the electron is held up, that electron is called sigma electron, and bonding is called sigma bond. I can show you like this. If there are, for example, one here and one is here, in that case these two orbitals are there, one is here, one is here, and they are overlapping like that. This overlapping is called sigma overlapping, and where the electrons are held up, these electrons are called sigma electron, and this bonding and you get is called sigma bonding. So that is the clear picture of sigma bonding, and this inductive effect is on the displacement of electron which are present in the formation of sigma bonding in sigma overlapping axis by axis. So here with this I will stop, and I will continue in the next lecture. I am going to discuss the second effect, that is called electromagnetic effect, and this effect is also playing important role in reaction mechanism and determining the rate of the reaction. With this I will stop. Thank you very much for watching the lecture.